Well, talking about customer needs, I'm delighted to open up our TOCS series today. It's the first one of our academic year, and I'm delighted to introduce Steve Mason, my friend from now with Samsung, but formerly with a company called Obscura Digital. Obscura Digital are one of the most creative companies on the planet. If you go to their website, you'll see some of the visualizations that Obscura does. And Steve has been working on a project there for 3 years that we've been involved with in a tangential way. Steve has been kind enough to have a number of our student groups work on projects while he's been developing this product. But what Steve's going to talk about today is going to be the technical details of a really interesting innovation project. And it brings out many of the aspects of entrepreneurship and innovation that we're going to discuss in some of our classes. But Steve is going to talk about the technical development of this product, which is an interesting case in point because it's a startup company working with a large company who are probably kind of conservative in the way they do things. And so the whole development of this really novel technology, which we actually brought down for our tech showcase about 3 or 4 weeks ago, was really in Steve's creative hands. So Steve was the Chief Technical Officer at Obscura?
The VP of Innovation.
See all these titles, you know what I mean? What do you call yourself in a startup? You just do it. And Steve today is going to talk about the evolution of Bluescape, which is a new way of doing things essentially for collaboration. And this was a creative genius that really put it all together. So I'm handing it over to you with that great.
Thanks. So, hi everybody. Thanks for the intro, Stuart. So yeah, this talk is one that, as you can see, it's from May. So I gave this talk twice, once in Graz, Austria, and then in Toronto. And as Stuart indicated, I'm sort of in between jobs right now. I've accepted a position at Samsung. So this is probably the last time I'll ever be speaking about this publicly. It's kind of my denouement, if you will. So in any case, just to give you guys a little bit of background, first of all, I just kind of wanted to give you guys a little bit of background about who I am and sort of my role in all this and why I'm interested in this. This was my first computer. If you're not familiar with it, it's called a Timex Sinclair. This was a computer that you hooked up to a black and white TV, and to load software into it, you either had to code it manually or you had to play a cassette tape via like an audio cable into the thing. So it took 45 minutes to load a program because you had to actually wait for the tape to play. So I started coding when I was like, I don't know, 5 years old or something like that. So that's how long I've been working with computers. But in general, I've always been interested in technology as a vehicle for art and for expression and for creating beauty. I'm also a musician and an artist, and so I've always used computers in that way. The very first things I did on computers were to create animations and create artwork and to create music. And I've also been very interested in general in the role of art, as I said in the previous slide, in collective mythology and storytelling and so on and so forth. The reason why I show this slide is it was very relevant for the last job that I held, which was Obscura Digital does lots of physical media installations, so architectural projection mapping, or filling spaces or creating surround cinematic experiences, basically things that are not contained within rectangular glowing screens that we have in our pockets or on our desks. And I always considered this early use of perspective, or it's called trompe-l'oeil, as an early example of using technology to help tell a story or to help to enhance the artistry or the mythology or the story that's being communicated. So just to give you kind of a little bit of background of Obscura, they've been in business for about 10 years, and or I guess 13 years now, and they really started off with hemispheric dome projections, so really creating this full cinematic surround experience, like a planetarium, but instead of showing stars, showing roller coaster rides and sort of synthetic alternate realities and universes and things like that. So I was there for about 5.5 years, and when they brought me in, I really started the entire interactive and sort of non-deterministic technology portion of their business. Prior to my arrival, Obscura really just was a kind of a video playback system on these big environments, and they said, well, how can we turn this stuff into something that's interactive? How can we connect it to data-driven technologies in the cloud and things like that? So that's mostly what I worked on there. There's some examples of some of the projects. So we've done projections on the Sydney Opera House, and we've done large format, as you can see there. This is in the San Francisco Public Utilities Commission. It's in the public lobby. You guys can go down there and see it. It's a huge 60-foot data visualization. It's obviously very illustrative also, but it shows the flow of water and power from Hetch Hetchy all the way down from the Sierra Nevada mountains into San Francisco. We've also done projections on a number of landmarks. Like I said, the Sydney Opera House is one, but we've also done the Sheikh Zayed Mosque in Abu Dhabi a couple years ago. This is a little bit more of a traditional projection piece in that it's really just playing back video. But I like showing this because it's a nice bookend to show the scale and also the artistry involved in doing something for this was a religious holiday actually, or it was the celebration of the 40th anniversary of the United Arab Emirates. That's what this was. And let's see here. So we've also done, I showed the Sydney Opera House. A lot of people have done projection on the Sydney Opera House, but again, typically it's deterministic, people basically pressing play. We did something a little different here where we did simultaneous projection on the interior of the Opera House and the exterior. And it was also all real-time generative media, so it was performant. So we actually were following the score and watching the conductor with the camera and everything. So we were actually making things happen live with the inclination or whim or fancy of the conductor, so that everything was synchronized, and it was very, very in simpatico, if you will, with the symphonic performance. We've also done work at the Guggenheim Museum in New York. This was also a simultaneous interior and exterior projection piece. So while there was all this really nice kind of a trompe l'oeil work on the exterior, let's see if we can skip ahead. There's also, we mapped the entire interior spiral and had real-time generative art mapped all the way around, basically reinterpreting these fine art video pieces into procedural content. So both the geometry and the texture maps and the animation was all generated on the fly, procedurally. We've also done a number of surround cinema environments. This is something we did in Las Vegas. We were actually never really able to get good photography of this. I shot this with my camera phone at our shop. Basically, the idea was this is the kind of room that when Britney Spears goes to the hotel, they put her in here. You push a button, the entire room turns into this three-dimensional landscape where there's strippers and sort of chrome flowers that open up, and it's very psychedelic and crazy. But anyway, so we've done a number of pretty crazy things. Yeah, sorry, I forgot that was in there. Yeah, but that's the other side of the cathedral. Yeah, the cathedral art. So yeah, in this slide. So now getting more into what I'm here to talk about, because it actually the Bluescape project was a genesis based on this particular project, which was a custom installation that we designed for the Hard Rock Cafe. The Hard Rock Cafe has, around the world, I don't know how many restaurants they have, let's say like 500, something like that. And they have about 2,000 or so individual rock and roll memorabilia artifacts. If you've ever been into a restaurant, you've probably seen a couple guitars or maybe a jacket that Michael Jackson wore. But they're all spread around all the different restaurants. So they wanted to figure out a way to see all of those at once. So we created a memorabilia archive, interactive archive. So this was an 18-foot wall. It allows up to 6 different people to interact with it and to access all of these assets individually. And they're really high-res photos, like 8K. You can scale it up and fill the whole wall, so it's all multi-touch style. I don't have a video of it, I don't think, unfortunately, but just kind of give you an idea. You've got some search widgetry down here, so you can look for your favorite band or your favorite genre and get all these really nice images. And this was a pretty successful project. was done maybe 5 years ago. There's 4 of the large format ones, and then we ported the software to work on a single HD touchscreen, and there's probably, I don't know, 250 of those installed at Hard Rock cafes all around the world. So that project got a lot of attention because it was, at the time, I think it was the largest multi-touch installation anybody had ever done, and I think actually to date it's still one of the only multi-user ones where each user has their own user interface and they can do what they want to do without interfering with somebody that's next to them. It's a really serious usability challenge to design a computer software that allows multiple people to work at once. In any case, Hayworth, which is a major furniture manufacturer, saw this technology online and they said to themselves, wouldn't it be great if we could use this technology in a collaborative workplace? This is, and you know, they're one of the world's largest furniture manufacturers. Okay, yeah, there you go. So this is the kind of company where when somebody builds, like, let's say, and you know, I don't know if this is their customer, but you know, like let's say Nokia opens up a new research facility here that can hold 5,000 people. Well, they got to fill it up with furniture. So this is like their one-stop shop. They'll call up Hayworth and say, we need cubicles, we need you to design the conference rooms, design the hallways. They'll do everything. And they have behavioral scientists that understand the different psychological archetypes of people and different ways of collaboration. So they really take this stuff very seriously. And they worked with us to start to think about how do we start to integrate technology into furniture. That was basically the premise. So this is their office in Michigan, just to give you a sense of scale. It's like a $1.5 billion a year company. And this is the type of stuff that they make. And this is their entire business is predicated on sourcing and manufacturing furniture in high volume. So it's a very different company than Obscura Digital, which is kind of a small 50-person sort of rock and roll Burning Man type company. So in any case, after a lot of negotiation and working out the details, we came up with this arrangement to have a joint venture. So there's a new company called Bluescape. You can go to their website, bluescape.com. And Bluescape is actually based in San Francisco. They're actually working out of the Obscura Digital offices currently. And they are continuing to design and build and sell the Bluescape product. So it's jointly owned by Obscura and Hayworth. So really when they came to us, Hayworth already had some understanding of what they wanted to do, or what they had a vision of how technology could be integrated into furniture and what specific functions it could serve. And this was really the low-hanging fruit. Chalkboards and whiteboards and foam core and post-it notes and 3x5 cards, which is it's once you really start thinking about it, it is kind of interesting because we do have a lot of really sophisticated high-end technology, but so much of design thinking and collaboration is still really not that far away from cave painting, really, if you get down to it. So there's this real disparity that exists between, or a gulf that exists between the technological development of collaborative materials versus what we have for personal or for presentation systems. Like we're using a projector here, that's kind of high tech, but if people still use chalkboards, I mean, there's paper on the wall over there, right? So it still exists. So anyway, yeah, there's whiteboards, and that's what we set out to do. Develop new technology which supports face-to-face collaborative problem solving. So that was our first set of boundaries that we established around after we decided, okay, furniture and technology, now what? Okay, this is our next set of guidelines. So what we did is we designed a continuum of immersive room-sized environments and personal computing devices. And we didn't create an Internet of Things, but rather a digital environment for people to use together physically. So there are companies that make digital whiteboards. I'm sure you have seen these, like Smartboard. And this has been around for 5 years or so, or 10 years. And we knew that they existed, and so we did a lot of research on what was out there. And we sort of set out to fill this out. The analogy I always use is, if you think about how different the iPhone is, or the the latest generation of Samsung smartphones compared to the flip cell phones that we had in the 90s. I mean, those things didn't really do much. They actually were phones. I mean, I almost wish we didn't call these things phones anymore, because it's, they're not, there's so much more. The phone part is kind of ancillary. So we set out to fill this question mark here. We wanted to create something that was so different and so much more advanced than a smart board that it almost made this look like comical, just in the same way that 90s flip phones are anachronistic. So we had to set out with some requirements in order to start the design process. So we knew that we wanted it to be large format. In other words, we didn't want to create something that was based on the limitations of a single HD screen, 55 inches or 42 inches or 65 inches. We wanted to say, hey, let's make a 30-foot by 10-foot experience, or really, really start big. And then the other thing is infinite workspace, and this was something that Hayworth was adamant about. One of the limitations of whiteboards and chalkboards is that you have a limited amount of physical space. I'm sure everybody in this room has taken a picture of a whiteboard or a chalkboard at some point in time, and they saw this as a pain point, and digital technology allows us to get around this. And there's a ton of different ways you can do this, but that was the premise. Real-time collaboration. What that means is if you have more than one device, that they're connected. And if something happens on one device, it happens instantaneously on the other device. So you get this real-time connectivity. The other thing they were very enthusiastic about was natural handwriting. They felt like it was very important to support writing instruments on digital technology. That's one of the nice things about chalk and pens and whiteboards, is you don't really have to know that much about the technology. You just have to have some basic facility or agency with your fingers and know how to write. So that's a low barrier to entry. Also open and extensible. We didn't really want to create this like monolithic application that had a given set of features. Everybody in the world is going to have ideas about how to improve and extend and enhance technology to suit their needs, and also to provide a vehicle for their own creativity. So that was an important aspect. And then broad appeal, which really just is ease of use and simplicity. So this was the landscape that we sort of identified that we wanted to cover. So we had to design not only software and user experience and interface for each of these individual platforms, but also look at them holistically and understand how they relate to one another, how they affect one another, and also how to handle discrepancies of input and output and scale. So, for instance, on a tablet, you have fingers and potentially a pen, but on a PC, you may not. So how do you design software that looks and feels the same and makes sense on both, even though your input methodology is going to be completely different? The other thing that was a kind of a surprisingly deep area of investigation was this relationship between public and private, and I still feel like this is in its infancy. The vast majority of technology that we have today is predicated on the idea of private ownership. All the phones that we have in our pockets and the laptops that we carry around are ours, and usually ours alone, with the exception maybe of like library computers. You know what I mean? So all of the standards that have ossified over the last 20 years of personal computing technology are predicated on this idea of personal ownership. And when you start to think about building software that is designed for multiple people to use simultaneously in a public environment, you end up with this whole other set of issues. So this is just this is a distillation of some of that investigation. One of the interesting things here is the authentication models. You can't have people typing in passwords in public spaces. You guys all know that the issues with that. And one of the other issues is modality. So I have here highlighted, with private, we have what I call discrete heterogeneous modalities, which means that you've got different screens that you can slide between. When you launch an app, the app takes over the screen. It's ad infinitum. But in a public computer, you're kind of forced to have this singular concurrent modality that everybody's using, but there's smaller subsets of things that can happen within that space. Also, fault tolerance is another big one. My phone crashes all the time, and I don't even really have that much stuff in it. And we've all gotten used to that. But when you've got a 30-foot wide computer, suddenly not as acceptable when you're interfering with the work of 15 or whatever people at once if something crashes. So it's completely different. The other thing that we started to think about, but we didn't end up necessarily designing a lot for, was different domain topologies. So really right now, I think most of the technology that we use in our daily lives is basically social or organizational topologies. In other words, like social media, email, for instance, all the connections that exist between our tools and our devices are abstract. They represent connections that exist between individuals or different organizations. But what we haven't developed a lot of yet, and this I mean as like humanity, is a lot of technology relating specifically to spatial and proximal topologies. So we have like GPS, and we have some location-based services, but it's not very high resolution, and it doesn't work very well indoors. And I've seen some of the posters outside, so I know that there's people in this room that have been probably doing a lot of thinking about near-field communication and low-energy Bluetooth and things like this, where we're starting to get higher resolution understanding of people's positions. But that really is still proximal. And what I mean by proximal is it just has to do with like physical distance between people. That's a very different thing than spatial. In other words, we all occupy this space, but there's another space on the other side of this wall. There might be somebody that's 1 foot away from me right now, and proximally they're closer to me than anybody else in this room, but they're in a different space. That's the difference between proximal and spatial. We ended up not really developing a lot of stuff for this, mainly because the hardware technology isn't really commoditized yet in a way that I think can be widely distributed. But I just wanted to highlight that we at least, thought about this stuff to a certain extent. So anyway, at the end of the day, this is basically what we're trying to create. It's a large format system where people can come up to it. There's some kind of media or application interface that allows people to manipulate it in a public environment that's visible to others. So I'm just going to show, actually, I did have a video. Well, I can just talk over this. This is a promotional video that we did in November, just to kind of give you guys a sense of what it looks like in action. But it's got a lot of me talking in it, so now you got 2 of me. Sorry. There is audio. You know what? It's not hooked up. I didn't. It's okay. Don't worry about it. I'll just get past it.
It's actually better to talk over it in some senses because you can see what the are.
I'm sorry? No, we had custom pens that we created. They have an infrared LED in them, and they're pressure activated. There's a really sensitive mechanical switch. The reason why we did that is because these screens that we're using have an array of infrared cameras behind the display element. And it actually emits infrared light, and what bounces off your fingers is detected as finger touches. But if you have a higher intensity infrared source, it's detected as a different category. So that's how it can determine the difference between a finger and a pen. So we had probably about a year-long R&D process that we entered into for this. The biggest challenge from a technical perspective was really how to create this contiguous experience of multiple displays. This is kind of this is a representation, kind of to scale, of what we decided was our largest realistic form factor that anybody could ever want to have. I mean, this would represent several $1 million of screens, so I don't even think anybody's ever going to buy this. But we had to make sure our software supported it, both from a technical and a design perspective. So it's 24 HD displays, completely next to each other with basically no discernible bezel on the screens, like maybe 1 millimeter or something like that. But we didn't want to create software that treated these as individual displays. We wanted software that treated this as a contiguous display. Because who knows, maybe 20 years from now we'll just have wallpaper that you go by, and it's not going to make sense to have software that expects lots of little rectangular displays. Or who knows, maybe it's spray-on LCD. Who knows? We wanted to make sure that we were thinking about things in a progressive manner. So that meant we had to drive 15,360 by 3240 pixels, and 60 frames a second was our minimum, because when you're writing, you actually, you'd be surprised at how important the frame rate is. I don't know if you guys have ever tried to use a pen with an iPad. And even that is decent, but there's quite a bit of lag, and that's a separate issue. The latency is a separate issue. But in order to make it feel good and to create technology where if you put this in a room, you want people to want to use this expensive thing rather than get frustrated with it and go use the piece of paper or the whiteboard that's on the wall, use their $20 solution instead of their $2 million solution or whatever. That would be a failure. So what we found out is that this is super exotic territory. There's absolutely no standards, and there's no commodity software to do this. So it was a real challenge. I did identify a number of tools and software packages that have been developed privately and also in the academic universe. XDMX is actually the oldest. This is it's an extension of the X windowing system. I think it goes back to the early 80s, potentially late 70s. And then Chromium is an extension of that. Sage and OmegaLib are currently being developed at the University of Chicago in Illinois at the Electronic Visualization Laboratory. Really, really interesting software. ClusterGL2 is a Google Summer of Code project, which is really interesting. CGLX is developed down at UCSD, down at the Cal IT Cinegrid department. Anyway, if you're interested in this kind of thing, this is a great list of things to look at. The two commercial ones on here are Cornerstone, which is developed by a company in Finland called Multitouch.fi. And Greenhouse is a new kit that just came out a few months ago, and it's developed by Oblong Technologies in Los Angeles. So here I just have some screenshots to give you an idea of what all these things look like. There's XDMX running multiple CRTs, multiple LCDs. Equalizer, by the way, Equalizer is probably the most sophisticated library that's out there that I know of, and it's currently maintained by a gentleman, I forgot his name, he's in Switzerland. Sage at EVL. The Cave system also developed at EVL. Cave is pretty cool. And then Oblong's Mezzanine. Oblong is a really interesting company also. And this is something that, this is a video demonstrating the Greenhouse SDK by Oblong. So I think this actually represents 3 different computers with 5 displays, and they're dragging content between displays. So they've created a model that allows you to define the physical position and orientation of each display. And so it basically allows you to write applications that run on all those devices, but they all communicate with one another. So really interesting technology. It has severe limitations also that made it not suitable for our project, but that's what's out there. CGLX, Liquid Galaxy. Okay, so there's different approaches that you can use to do this. The most obvious one that a lot of people do is they use, for however many displays they want to use, they have an individual computer driving each display. And what that means then is you've got software running on all these CPUs, and then you basically have a network you have to work against network saturation, synchronization, memory distribution, all that kind of stuff. You know what I'm talking about. So basically what you have here is your stack. Just to assume that this is 3 out of 20. Your applications are speaking to one another, but then each application is doing your textures and your graphics primitives, draw calls, rendering the pixels, going down to your physical displays. There's a couple other libraries like ClusterGL2 and I think Equalizer is capable of doing this also, where you really just have one single computer running your principal application layer, generating the primitives, and then the OpenGL draw calls and the textures are distributed over your network, and then each computer, this is basically just going pretty much straight to the graphics card through some sort of a soft layer that interprets the network packets, renders the pixels, and goes to your physical display. And then there's pixel scraping, which really requires fiber because you can't you saturate your gigabit Ethernet pretty quickly with this. But basically everything is done on one computer, and you're just shuttling out raw pixels. It's kind of like a VNC type model, which works really great because it simplifies your application pipeline. But like I said, the network saturation issue becomes an issue. It's not easy to maintain either. So what we ended up doing is a single computer that drives 24 displays. A little bit of a brute force approach. So what we did is we hooked up, I think it was 4 ATI graphics cards into a single computer, and each of those graphics cards had 6 outputs. So that allowed us to render to 24 displays off of a single machine. No network saturation issues, none of that. So, but it had its own issues also. So this is just a photo from our lab at Obscura. We had 4 actual LCD touchscreens. We couldn't afford to get 24 of those, so we just hooked up a sort of a proxy of just racks of HD monitors just to make sure that we were actually rendering correctly. And here's a video of it of the Bluescape software running on 15 displays. So you can see it's not too shabby. It's running at 60 more or less. There's a little bit of a synchronization issue, but it's pretty much negligible. I think I'm zooming in and out here a second. There you go. You can really get a sense of everything working in concert. This approach had its own challenge in that we had to manage memory between 4 different graphics cards in a special way. So we have a pretty good C++ engineer who wrote everything from scratch, and this all runs on Linux. So we basically ended up writing a master program that has 4 slave applications, and those slave applications really just handle the draw primitives and draw calls and textures and things like that. But it's all running on one computer, so the IPC-Q issues are negligible compared to shuttling all that stuff over a local area network. So that was a major sort of technical issue. The next thing we really had to start thinking about was just the design of the software and the design of the user interface and user experience. This is really the distillation of what we wanted to achieve, and this was an important thing for us to identify before getting too involved with the application development, because we wanted to understand what it is that we're trying to do. And one of the things that Hayworth really highlighted for us was, again, this idea of collaborative problem solving in the workplace. So we really wanted to make sure that everything we did was in service of improving this particular activity. And so the first thing that we did was we really started to try to understand what the different behaviors involved are, and to reduce those down to a small set. And the reason for that is every feature and function that we implemented needed to emanate from the behaviors that we were trying to support. So the first behavior is creation. We want people to be able to express thought through drawing, writing, and refining. Gathering, so aggregating and arranging content for consideration and sense making. So that includes anything. That's photos, that's documents, drawings, anything that you can get. The analogy there is if you ever see rooms where people just have magazine clippings and photos just pinned up everywhere, that's aggregating and arranging for sense making. Sharing, kind of self-evident, but content is presented or referenced in service of the assessment or deduction of facts, and really that's kind of what all this is about. And then facilitation, which is kind of a meta behavior where you have one person guiding a session by framing challenges, moderating conversation, clustering and arranging content that has been aggregated, and acting as scribe. A lot of times with post-it note sessions, there'll be one person that writes things down, sort of listening to what people are saying in a group environment. And then the core use cases, the different arrangement of people that occupy and inhabit spaces either in the same location or across distances. So the first one is people using their personal technology devices to access this collaborative problem-solving tool from anywhere in the world, cafes, whatever on the street. And then the next one is where we have different wall size devices, or small of any size, in different facilities where people are able to communicate and collaborate remotely, with ideators contributing with their personal devices either on-site or off-premises. And there's also a situation where we may have more than one person using the same writing surface at the same time. And then once again, we have a facilitation system. So this really helped us just to identify every sort of possible combination of humans that we needed to address. And the other thing we really had to think about was these metaphors, and this is something that I thought was kind of a fun problem to tackle, because we still talk about files, and we still talk about recycling bins and trash cans, and all these things obviously are holdovers from desks, and obviously the reason why the Macintosh or Xerox or whoever came up with that stuff was because they were trying to make it really simple for people to understand. And I think that one of the most significant innovations that was introduced by Apple with the iPhone and the tablet was they had the courage to abandon some of those metaphors of files and desktops and things like that because they weren't relevant anymore. New metaphors or new ideas or standards were established for personal technology with phones and tablets. So we saw this as an opportunity to reconsider what we take for granted and really think about what are the metaphors that are appropriate for a wall device, right? We don't want to have a desktop because it's not a desktop, And we thought about it a lot. It may seem really obvious, but we did at least go through the process of thinking about it. And really what we came up with was this idea of notes as being our sort of principal element. And notes are the foundational building blocks of externalized thinking in the physical world. And they have a lot of really great properties. They're spatial, they're modular, they're immediate, and they're flexible. And the other thing that's nice about them is it forces you to condense and distill your thinking into chunks that can be rearranged and modified really quickly. It's a lot more effective to iterate on ideas that are expressed through a bunch of post-it notes than it is to pin up a single space 8.5 by 11 page that you've printed out, because you can't, it's not really malleable in that form. So once we had that sort of established, then it really just became a question of like, okay, how do we handle or how do we manipulate or create these cards on different devices and platforms? So we know that we wanted people to be able to create them on their laptops and their tablets and on the wall. And the other thing that we thought would be cool is if people could use a tablet to create a note card and then sort of, flick it off the top of the screen and it just shows up on the wall. That's kind of a cool magic technology moment where the technology is starting to do something that you really can't do with Post-its, unless you're really good at throwing Post-its. Right. Yeah, that's a skill. So this is actually the very, very first mock-up that we did to show what does this stuff look like? What are the colors? What are the, what does text look like? What does our drawing, what does our drawing menu look like? And one thing you might notice right away is, we have a dark background. I think it's one of the kind of errors maybe of some of the smartboard technologies. They still use white backgrounds, and that's fine on your phone or your desktop. But when you've got a 20-foot wide by 10-foot wall, the last thing you want to do is put your eyes and or stand 2.5 feet away from that. It hurts. It's not pleasant. It's it's like sticking your face in front of a TV. So everything has to be sort of dialed back, and when things are bright, you want it to be sparse and intentional. This is an evolution of it where we started to explore different colors and arrangement issues and grids and things, sort of snapping to a grid, and also looking at, what a video player might look like. So you can see we've got some controls over there for a video player. We actually spent a lot of time thinking about colors. We did not want to give people a HSV slider wheel for Post-its and for drawing. The reason for that is it's not so much that in the long term we want to reduce people's ability to use whatever color they want. It more has to do with making aesthetic decisions for people that may not necessarily be aesthetically inclined. Most people in the world are not artists, and furthermore, in the creative, collaborative, problem-solving environment, that's not really the right time for people to be making things look pretty, for lack of a better term. They're there to talk about concepts and ideas and abstract things. So we wanted to sort of remove that layer of decision-making from the equation. So each one of these columns here sort of represented a candidate for what's the equivalent of a pack of Post-it notes. And ultimately what we came up with are these. So these are really the signature colors of the Post-it notes that we have for the Bluescape product. There's more in there that we added later. This is our secondary palette. But when you first start out, when you bring up your Post-it creator, those are the 5 colors that you have access to. And it just helps ultimately to give the product a sense of identity, so that when people see it, they recognize it, and also to give people just enough variety that they can create emphasis and distinction in the areas where it's needed. I mean, really, it's the same reason why you have 5 colors and 3M Post-it notes. Same idea. So we spent a lot of time thinking about grids and organization and sizing. You don't want to be able to scale them down necessarily infinitely small, and you also don't necessarily want to scale them up infinitely large. There's usability issues that start to arise with that. One of the other major challenges that we had was to come up with a system that was going to make sense no matter what scale device you had. The number of physical pixels that you have on your phone or your tablet or your laptop is a lot different than the 15,000 by 3,000 pixels you have on your on a big wall installation. So these are just some studies to demonstrate looking at different relationships of scale, composition, volume, etc. And then in terms of looking at interaction, more getting into the pixel visual design, one thing that we talked a lot about was skeuomorphism. I don't know if you guys have heard about this before, but it has been in the news a little bit lately with Windows 8 and the introduction of iOS 7, which has a much flatter look. It's less sort of bevelly and shiny and reflective and cork and thread and all that sort of stuff. And I have kind of my own definition of skeuomorphism as it relates to anthropomorphism, where anthropomorphism is the attribution of personal characteristics to non-human things like dancing tea kettles and Disney movies. And skeuomorphism is like the attribution of physical characteristics to non-physical things, like computer buttons. They're not actually physical, but even just the motion and movement, fading, bevels, glosses, all that sort of stuff is embedding physical characteristics. And the reason why that has been the case in user interface design for so long is, again, it makes it more understandable for people. It connects it back to the physicality of the real world. So this is an example of what I would consider to be extreme skeuomorphism, where there's jagged paper, stuff that has absolutely no bearing on functional relevance whatsoever. And this is Windows 8, obviously, with almost no skeuomorphic attributes. And then, obviously, iOS 7, which is heavily reduced in terms of gloss and sort of dimensionality. And we ultimately decided that we wanted to try to hit as close to this mark as possible. This is the work of Dieter Rams, who's a really famous product designer. Did a lot of design work in the middle part of the 20th century with consumer electronics products, radios and turntables and telephones and things like that. But they're very simple and minimal and clean and sort of almost irreducible. As a matter of fact, the original iPod was almost a direct ripoff of a portable radio that was designed by Dieter Rams. So these were our visual design goals. We wanted it to be elegant. If for no other reason, this is a really expensive product, and we don't want it to look like it's something that somebody just cobbled together really quickly. We have a CEO spending a lot of money for something, probably has good taste in watches and cars. This product should probably look nice also. So that was really important for us. making it modern, simple, and friendly. So this is sort of where we ended up in terms of our overall look and feel. This is a signature user interface concept that we came up with for the Bluescape. It's called the PAL, which is kind of a triple entendre. PAL is in it's your buddy. It's your person. You're confused. You don't know what to do. You bring up your PAL. Your PAL's going to help you out. Secondarily, it's also a personal asset library. So if you have assets that you have from somewhere else and you want to figure out how to get them into the system, this is how you access it. And it's also your personal application launcher. So you can see along the top here, there's a row of icons very similar to what you might see in the dock of OS X. And this is how you launch applications. So you can see we've already got some obvious things, right? A calculator, a note card or a notepad. We've got a web browser. This is like a remote desktop viewer, like a VNC client. And we've got tools that you can use, arrows you can use to go left and right to scroll. And the idea here is that when you choose an application, you get a preview of that application in this content area. And once you get everything set up the way you like, you go to the web page you like. If you're creating a note card, you can try writing on it. If you misspell something, you can erase it before anybody else sees it. And once you've got it done, then you can drag it out of the PAL into the workspace. And that's when it becomes visible to everybody else in the world that maybe is remotely connected to your session. Here's that same sort of aesthetic being applied to some of the other user interface elements. So you have to have a keyboard. People have to be able to type in URLs and things like that. We have a really simple instrument selector, so you can choose different types of pens and markers and eraser tools. And you can also start to see post-it cards. And also here's one maybe egregious skeuomorphism detail, like a little push pin to indicate that the card is locked into place. That's actually really useful because it prevents people from accidentally flinging stuff around all over the place, which happens a lot. So this isn't ours, but this is something that I downloaded off the internet. This is a toolkit Photoshop file that these guys, Tehan and Lax, made. It's a Toronto design company. It's basically just a collection of all the different little budgets and buttons and sliders and drop-down boxes. It's like your spice rack for applications. This is the tools that you can use to put everything together. And we knew right away going into this that we were going to need to build something similar for our system to allow people to build and assemble their own user interfaces for their own applications. So this is an example of that. This is actually some that our designers made to show all the different sort of standard widgetry that you need in order to build an application. And here's a video of it in action. So I'm bringing up the PAL, and I'm going to choose my note creator. So there you can see I've got my different colors, and I can type into them with lots of typos. And now I'm going to bring up a clock widget. So I can choose my time zone and my clock face. And it defaults to the upper left-hand corner, but now I have this like desktop widget. It's really similar to the same thing you have in your OS X and Windows, right? You just have these little things that float around, and you can have whatever you want. You can have stock tickers, you can have anything you can imagine. So we have sort of a set of actors, interface actors that you may have seen there was a menu that comes up. We call that the base menu. It was actually, we went through several different iterations of user interface design for this, and it was challenging because on one hand, in an ideal world, we didn't want to have buttons all over the screen. We wanted to keep it as clean and as content-driven as possible. So really, there's one UI menu that you can access. So you go up to the wall and you just touch your finger down for like 2 seconds, and this little base menu comes up. And we intentionally reduced it down to like 3 different options. You can choose to draw. You can choose to zoom. I know that the icons are different, just ignore that. But you can draw, you can zoom out, and you can access the PAL, which is represented by the cloud. So if you're confused, if you're a new user, you don't know what you're doing, you've never seen it before, if you look at this, you can probably discern what to do. We hope so, anyway. 3 is better than 1,000,000, I guess. So then we have the drawing palette. Again, we tried to keep it really simple. We're not giving people HSV sliders and stuff like that. It's like, do you want a red pen, do you want a white pen, or do you want an eraser? And you can scroll to get to different instruments. And then also we have drawing boundaries, and this is probably one of the more complicated aspects of the UI. If you have a wall that is 20 feet long and you've got 2 different people up there on either end, and the person on the left says, I want to draw in red, and the person on the right says, well, I want to erase. How do you give people the ability to do that independently without interfering with one another? Especially if one person starts to write across the wall, or they cross, or something like, whatever. There's all these weird edge cases that come up. So we came up with these boundaries that come up, that appear when you bring up a drawing, a drawing palette, and that indicates to you the extent of the mode that you've chosen. So you can have multiple areas on the wall that are in different states. So different people can be writing in different colors with different tools. The reason why that's the case is that our pens do not have any sort of identification. The computer system cannot tell the difference between pen A and pen B at all. When that problem is solved from a technical standpoint, the need for these will vanish. So here you can see 2 different people at the same time. And then we have the tablet, or the PAL. And also the original idea of the PAL was that the interface would look similar on the tablet as it would be on the wall, so that when people look at something on their tablet first, when they see it come up on the wall, there's a sense of familiarity and comfort. And I think, am I running out of time here? Okay, sorry. Just for different user interface elements, keyboard. We've also got a bird's eye view. We looked at all the different types of writing instruments. I went down to the art store and bought every single marker that they had, just so that I could look at the tips and also look at how the writing looked. And so we picked out different ones that we like to actually try to emulate with code. And this is just showing. So we have an iPad application. We have an HTML5 client of the software so that people can access it on a browser. There's an iPad menu. We have this 3-screen version. You've seen the 15-screen version. And then this really is just talking about the fact that it's an operating system. And I think this video shows a Wikipedia browser. So it's not just this monolithic application. We actually implemented an application framework where apps run as separate processes, not as separate threads. So it's very similar to the design of Windows or OS X. So when you run a web browser, it's actually running as a separate process and on the computer, so that if it crashes or anything, it's not going to bring down the whole system. It'll just crash that one application. And so we've created a whole SDK and an API that allows people to build applications that can populate the PAL's application launcher and run in this way. And just to prove the point, we have a bash terminal. Yeah.
Your microphone when you speak, please, for our remote guests.
Have you thought about integrating the voice and what the issues are going to be with that, so that you could say, save all this work today, and then the next day walk in and say, bring up yesterday's work, or somehow integrate the voice so that you're not always having to emulate typing in on a keypad versus being able to interact with the system?
We thought about it. Yeah, we thought about it. It's just one of those things that we don't, there's not enough engineers on staff to implement it. So, well, and the good news is actually with that a lot of that stuff is becoming commoditized and can be implemented later. You got to walk before you can run, though. That's the main thing. So a lot of these things that I showed you are still really in beta. So it's like we want to get all that stuff working as well as possible before we start layering in add things. But yeah, absolutely. The simpler and more natural we can make it, the better. Totally. Not yet. Not a fingerprint, no. No, the cameras aren't that high resolution. They just see like a white oval, basically. Yeah. So yeah, the rest of this stuff is really just like user experience wireframes, interface wireframes, matrices, first beta customers. So we showed this at NeoCon in June, and which is a big furniture show in Chicago, and this won Best of Show, which is a really big deal for Hayworth. It's an international forum, but then again, it's competing with desks, so I don't know. It's like, maybe not a fair competition. So this is what's next. Proximal topology. Like I said, we don't have any way to really understand, whether or not somebody's in the same room. It's all done via passwords and stuff still. Internet of Things is definitely going to change the landscape tremendously, and as that stuff develops, we're going to probably be looking at how to integrate that. And also, just in general, ubiquitous computing, where you've got processing power all around you, not just in your personal technology, but your environmental technology. And then, Google Glass, and who knows what Apple, Smart Pants or whatever, who knows what they're going to come up with next. But all that stuff is going to end up sort of evolving that landscape. So there you go.
Thank you, Steve. That was a really interesting presentation. Thank you so much. One of the things that comes to mind observing this whole process at work is that you always have to make trade-offs. There's always so many nice things you could do, but you've really got to concentrate on those. And that gets even more complex when you've got a team from another organization that have a different set of objectives in mind too.
That's right.
How do you resolve those kind of issues? What do you say?
Backstabbing. No, I'm kidding. No, it's like, no, it's no,
usual organizational life.
I'm kidding. It's a challenge. I mean, obviously you want to have an ideal situation where the merits or lack thereof are presented in an egalitarian fashion, and sometimes that works. Sometimes people have bias about things. One example I can bring up is, Hayworth was very, very steadfast in this idea that they wanted to be able to play back a session from the beginning. So you have this whiteboard where it's been annotated and stuff has been introduced, and they were like, there's so much value in being able to go back to the beginning and press play and watch it unfold over time. And that's true. It is pretty interesting. Maybe there's something you could learn about that. But it maybe isn't necessarily the single most important thing. And so then it becomes an issue of, well, how do you come up with criteria to qualify the relative merits of each of these things? And, you can do, there's entire disciplines based on how to solve these problems with market research and things like that. We didn't really do a lot of that, so it was more just based on, well, actually, in that case, nobody ever decided not to do it. It's just you couldn't do that until you had all these other things even done in the first place. So there's sort of a natural shaking out, if you will, of that prioritization process, just by virtue of, well, you can't even do that until you have this, so that means you have to do this first. Yeah.
What are some? There's some questions here, please.
Quick question about the touch.
Yes.
Touch interface. So I noticed you have basically simple drag and press and hold.
Yes.
Do you have any kind of like multi-touch? Or
We did.
Tap or anything?
The only true multi-touch one we have in there is just the kind of standard pinch and zoom. We had all kinds of double tap and like 3-finger, 4-finger, this and that and the other thing. And I ultimately decided to try to avoid that stuff as much as possible, simply because we had established that one of our design principles was that it needed to be usable by people that had never seen it before. This technology might be in a room, a public collaboration conference room. Somebody walks in and they've never seen it before in their entire life, and there's nobody else there to train them. And we wanted to make sure that they were going to be able to figure out how to use it as much as possible without having a manual or some long learning process. So I think maybe eventually we'll add that stuff in as like shortcuts, but I think the idea was to try to reveal all as much functionality as possible through the simplest set of interface gestures. And so that's really more, that's just kind of like a design decision. Yeah.
Okay, so a couple more items for the have you thought about this list.
Okay.
One is any kind of like connect or leap motion style gesture interface, because like if I'm up close and personal working on details of something, that's fine, but maybe I want to take a step back to this distance from the wall and contemplate the big picture.
No, that's an interesting question. Yeah, we did talk about that quite a bit. And again, it's definitely something that I think has merit and can be added in at some point. It's just we didn't start there, basically.
Gotcha. And the second thing is, if I want to collaborate with somebody that's on the other side of the country or somewhere, have you thought about a way of trying to connect a couple of these together?
You mean in terms of like video?
Yeah.
Yeah.
The whole collaboration experience.
Yeah, I mean, kind of the poor man's version. I mean, it was just kind of ridiculous because it's so expensive. But basically, the idea is because we have a VNC capability in there. In other words, you can see your laptop screen on the wall. We figured we would just let people use their existing video conferencing technologies like Skype or Google Hangout on their laptop, and then they can connect that to the wall so that you can use an existing service without having to integrate it. Eventually, we will probably do that, but it's just to get out of the gate as fast as possible. That's the interim solution.
Gotcha. Yeah, I was just thinking about in terms of if I want to have multiple people collaborate on a single set of notes or a single note or something.
Yeah, no, it's a challenge. It's a serious design challenge.
I'm sure we will be chatting with Steve outside when Marisol has the usual social session there with some cookies and things like that. But I wanted to ask what are the kind of use cases where people are starting to apply this technology now, Steve? What are the sort of top 3 or 4 areas that you see it kind of moving in?
Well, against the original intentions, it's a really effective presentation tool. When I say against original intentions, it goes back to this idea of, what business activities do we currently have technology for? And we have technology for presentations. I'm using it right now, right? And so they were like, well, we don't want to try to make a new presentation technology because there's already stuff to do that. What we don't have is good collaboration technology. And it functions as collaboration technology, but it really is really good at presentation technology. It's kind of it's unintentional. It's better because you can interact with it. It's more personal. It's more gestural. It's theatrical. It's human. It makes presentation a little bit more human. And I think that's a kind of an unintended side effect of the product.
Well, if you haven't any more questions, I'd like to formally thank Steve today for coming down from the city and explaining us the evolution of this new technology. It's nice to see innovation unfold. It unfolds in an organizational environment. It's not sort of just engineers in a room developing things, and that gets kind of political, it gets economic, and it's a whole host of things. It was really interesting observing how a small company works with a large company, which is, I think, a playbook that's kind of currently out in the valley big time now, and we'll see a lot more of that. But more importantly, I think it's important to see the human perspective that Steve brings to bear. Steve's an artist, as well as an engineer and a scientist. And I think it's great to see all of these things coming together to create a new technology that, quite honestly, when you see it, and we had a screen down here for the tech showcase, and everybody's jaw just drops when you see it. It's just a phenomenal tool. And it's just starting to sell. It's going into its first customer as we speak. And I think you're going to see quite a big sort of penetration of this thing in boardrooms and corporate suites, in architectural firms, in a company not too far away from here in their new headquarters. And so I want to congratulate Steve on producing this wonderful technology and wish him well in his new role at Samsung, where I think we're going to see even more interesting things. So on behalf of all of us, Steve, I want you to remember your trip down here by always being able to wear something from Carnegie Mellon.
Right.
And remember,
now I can trick people.
Yeah.
All right. Thank you.